Okay, so let's move on. So we've covered the short lecture on file input output. This should get you ready for the tic-tac-toe piece that'll be available this Thursday. Will be due next Friday, not this Friday, but the following. Okay. So now we go into arrays. Okay. So let me go here. So in C++, we can create the legacy list and get a very good understanding of what we're going to be doing in the next few lectures when we write a simple class that is like a poor man's version of the C++ vector class. Okay, so let me go here. So we have this. Which time do we have? Yeah, we have enough time. It's just one variable, right? So if we map this to the stack, the value here would be 5, some number, and then we have others. We'll be working with integers, so I can at least pre-number this guys. Okay, so when we create integer num equals 5, then we have one variable, like one element. No more, no less. It's just one. We can create a list of numbers that go onto the stack, and then we will be using 1, 2, 3, and blah, blah, right? Maybe if I say const int, and then I can use this as the example. Capital S-I-Z-E, size, okay, 5, maybe 3, because I don't want to draw too many. Okay, and then this goes away, and it's 3, right? So count size equals 3. So it takes 4 bytes. It's on the stack. It's just one element. We can create a, where's my Visual Studio? Before I forget, let me check this in. Okay, so let me commit this. That way they go in as 2 separate check-ins, and it's easier. If you want to go back and look at my examples, it's easier to find them. Okay, so now we can come back here and number 10 now. So we go to SRC examples, CMake list. Well, I am the wrong one. Yep, this one. And we go to number 10. And we go here. Actually, let me go to CMake, configure all projects, make number module 10 buildable. Okay, so now I can start writing some code. Use stack array in the CPP. Okay, so we have a const integer size equal 3. I diagram that, and then we can create a list of integers, and we can say numbers of size creates a list of, or array of 3 elements. So then we're like, okay, so let's go back to our diagram, and then we have int numbers size 3. So then it's here, and it'll use one, 2, 3 times 4, 12 bytes. So 1, 2, 3. 3 memory slots on the stack. What values does it have? Whatever values were last at this address, at this address, and at this address. And we can confirm that. We can say, okay, for integer I equals 0, I less than size plus plus I, see out numbers at I, new line, oops, using cout, include IOString. Okay, so we're okay now. Come back over here, module 10, example 1001, run in terminal. This guy has an extra greater than, let me remove it. Oh, nothing happened because, well, I'm not using anything right in main. So it compiled, but I need to make sure I tell it to do something. Use stack array. Run in terminal. And notice, as I stated, whatever values were in those 3 addresses, when we allocate those addresses by using this syntax right here, meaning create an array of 3, 1, 2, 3. Okay, so we can come back to this code, and we can tell C++ to initialize them by using the open close curly brace. And at that time, if we use a curly brace, then it'll output, it'll save zeros into those addresses, and then we can verify that. 0, 0, 0, and it's always good practice to initialize our arrays. Also, it's important to understand that we still have a block for the main activation record on the stack, okay? So all this code here is within the main stack memory. Okay, here. Okay, so and that's how you create a legacy list. Before, like in the 80s, sometimes developers did not want to use the size. So then if they knew they needed, say, a list of 3 elements, they would purposely create a list of 4 elements. and the fourth element, they would use a value they knew that would never exist in the data set. Say they were working for some magical reason with positive numbers only, then they could assign -1 to the last element, and then they'd loop, and they'd say like, well, numbers of I not equal to -1, keep on looping. Once it would be equal to -1, then it would mean, oh, I'm at the end of the road, I'm at the end of the loop, so then the loop would exit. Okay, that concept, or that is a sentinel. That's called a sentinel, right? Not as predominantly used anymore because of the recommendation to use C++ containers, meaning a C++ vector or the other lists that are in the C++ standard library. You probably want to use arrays maybe where memory is limited, like in drivers. Maybe they're better off using arrays and managing that piece themselves. Maybe like for a small list that never changes ever, like a calendar list, like we always know we have 12 months and 12 months, right? Unless for some magical reason a 13th month would be added, so that would be a good case there too. But the recommendation really is to stay away from those unless you really have a good reason to use them, right? And instead to focus on using the libraries that C++ provides. Okay, why do we cover this? Because you might run into code like this if you are working with Java or C++. I think I'm not sure. I think C# supports them. I'll have to double check that. So, and also to teach students about memory management concepts, right, on the stack and on the heap. Notice here we don't have a heap, meaning, oh, so this is not on the heap, and yeah, it's not on the heap, right? Okay, what about an array of strings? So I'm not gonna write that code. Instead, I'll just say, well, maybe I should write it. Let me see. I did that for the other class. Yeah, I did. Okay. So if we go here and we write another function and we'll say array months, and then I'm not gonna write out all the months. Okay, I'll just do 3 of them. I'll just say 3 for now. We're in a different world. Okay, so int string. I don't think I've included string. Let me include that. And if it seems that I'm going faster than other times, well, I am trying to because I need to cover this lecture. Okay, so string names num of months. Okay. So I've created, I included string, yep. So I've created a string array of 3 names. Okay, I want to come back over here. Diagram this. Okay, again, we are still not using dynamic memory, and we will not use it today. We gotta get our foundation first, and then so heap, not yet. Actually, for this example, indirectly it's used for us. So when we map this, then we know this one goes here, and then we're like, okay, so what about string, about names? So this would be Okay, so this would be number 3. And this would be string, the first string, the second string, or the third string, and with indexes 0, 1, and 2. What's in here? Whatever's in memory at the time we request that. Actually, no, because strings consume memory. They will be pointing to somewhere on the heap. Let's say that the first string they assign, let me get a color, the first string, the second string, and the third string. So then okay, so that's what's happening when they're not initialized. And then if we decide to initialize 2 values, then we can say January, February, and March. Those are the only 3 I'll do right now. Then you can get an idea of what this would look like. So then this would be March. This would be 1 byte. So this would be maybe like 95, 94, 93, 92, 91, 91, 89, 88. Why 1 byte? Because that's what's needed to hold the number the string represents in the ASCII table. And this is how a string of would use if we would initialize it. Okay, so it's important to understand this because this is what we'll be headed toward on the next lecture. Okay, we ourselves will create dynamic memory. For now, the string is doing it implicitly for us, and the string will create it, use it, and delete it when it's not needed anymore. Eventually, we have to learn how to write that code. Create memory, use memory, clean out memory. Okay, so I've created that diagram. Questions here? Okay, if we go back here, we can also provide values ourselves. So we know we have 3 elements. We can say, well, the first one's number 3, the first one's 1, the second one's 5, the third one's 315, right? And then we can, well, let me see, let me backtrack here. Oh, Control Y. Okay. So we have this. Let me finish this example. I was jumping ahead. So you saw the diagram, and this code will work, right? We can say for integer I equals 0, I less than num of months, increment I, cout names at I, new line. Go ahead and go to main, comment this one out, and then we'll say, what was it, array months, and we run that piece of code. And notice we don't have to worry about deleting or anything. Why? Because they are variables on the stack. So when we use variables that are on the stack, C++ takes care of that for us, which also means that our memory is limited, right? So notice here Jan, Feb, and March. They output correctly. So before in legacy coding, sometimes programmers in C had to use parallel arrays, meaning like if they wanted to link data together, then they had to create 2 arrays. Say they wanted also the number for the month, right? So then they would say, okay, month number, num of months, and then I guess I'll initialize them here. You can say initialize it, the first one to 1, the second one to 2, the third one to 3. And then over here, I can say, okay, see out the month number at I. And notice parallel arrays, they are linked together, right? Because January is the first month, February is the second, and March is the third month. So they're linked together. After that came the precursor to class, which was the struct, which we don't cover in this class. But struct is the C version of a class, and it was used to store data more or less like we did for the temperature guy. Let me see here. Where's that example? Module 8. Oops, I need the header. If you would replace class with struct, then that would be what I'm talking about, right? So we could, instead of class, we would say struct, and it would be just, will work fine. That's how they will use records in C, but I don't cover that a lot because I've not seen it used extensively in modern C++. So then before that, this is how they would link records together, like with arrays that are related, meaning parallel arrays, and then we could work with records. So let me jump back to this one, run in terminal. Thankfully now, as we saw last week, with polymorphism, we can create a vector of with a hierarchy, inheritance hierarchy, and then we can add different variables, and then we are working with one class, but different data types within the class. So we don't have to worry about creating these parallel arrays because we can stuff those classes into vectors. And using polymorphism, you saw that a bank account can be a checking account, a savings account, and others if we created them. But this was C, and you can see like those developers had to work with stuff like this. So to keep that data organized was probably a big headache for them. Okay, now let me jump. Well, I was going to talk about initializing. Notice that I said 1, 2, 3, and look at the output 1, 2, 3, meaning oh. So using the curly brace, open and close, I can initialize, and you can skip one. Like you could say like 1, 2, and the third one will be 0. So you can partially initialize the list. Notice the last one is 0. Not what I want to do, and here I know that I want to initialize 1, 2, and 3. And then if I run it again, then I have January, February, and March. Also, if you want to compare a vector, you have to loop through the vectors. Imagine you have parallel vector, right? Say we have numbers and numbers 1, and they have different numbers. You cannot say if numbers equal numbers 1, because that will not work. Okay, why won't it work? Because you'll see in the next section, right? So in the next topic. So let me find my notes for that one here. And array functions. Okay, let me close this. So you know about pointers. Where did I save it to? I think I just put all of them in the same file, just so students just find all the examples here. So I'll do the same thing here. Okay, so array and pointers. And then you'll see why you cannot compare arrays by comparing their name. So we have this here, cout, numbers, main, array and pointers, output, and let's run this program. Notice address. So if we were comparing arrays numbers to numbers 1, what is this numbers that it output? It's okay, not this one, this one. It's the first address to the array. So they would never be equal because numbers would be in one slot. If we created numbers, say 2 over here, then this address is always different to this address. So we'd be comparing, is 96 equal to 84? Never, it'll never be equal to. So that's why we do not compare arrays like that. We have to iterate through both arrays with an indexer and then say, is numbers of I equal to numbers 1 of I? And if one of them is not true, then we return false and we know the arrays are not equal to, okay? But why am I labeling this array and pointers? Okay, so there must be something here. So we know a pointer, right? We can say a pointer can save an address. Is numbers an address? We just proved it here. We see out numbers, it spits out an address. So we're like, oh, so meaning I can say numbers here. Well, so far we're good, no errors. And then we're like, okay, I know that if I want to display the value of a pointer, I have to say asterisk pointer, and anyone, what's going to be displayed here? Let me add values here to make it interesting. 1, 2, or 3? One, right? Why? I just gave you the answer before, right? I said that the numbers is this address, so whatever value is at this address, that's what it's going to display. And I have element 1 with value 1, so it'll display 1. Let's go ahead and run this. One. Interesting. So a pointer can point to an address. Numbers is an address, so the pointer points to the first element of an array. Okay. So what about a pointer addition? What if we say, okay, pointer plus plus, actually after the cout, and then cout again, and now what do you think we're gonna see here? Let me run it. We may have to stay like an extra 5-10 minutes just to make sure I get through everything. Okay, so two, and I guess this one will output 3. One, two, 3, and finally minus. How is that happening? One, two, 3, 2. 1, 2, 3. Go back 2. So how is that happening? Let's go back over here. Memory offset index times data size. We know a number is 4 bytes, right? So 0 times 4, 0. So 96 minus 0. So it's this value. And then if I say, okay, index 1 times data size, 4, 96 minus 4, 92. 2 times data size, 8. 96 minus 8, 88. So internally, there's math going on to get the memory offset and help the pointers know where they are at, okay? The programmer still has some work to do, right? We need to know that we cannot go beyond the boundary of the array, otherwise we are going to go into memory that may not be in use, okay? So that's how that's working. Okay, let me see here. So void display array. If a pointer can point to an address, then we can set up this structure. We can say pointer to a number nums size, and then we can come back over here. Oops, not that one, this one. And then we can say for integer I equal 0, I less than size plus plus I, cout nums at I. Of course, we have to make sure that nums is an array, right, when it comes in, otherwise our code's not going to work. And then I can just copy this into main, put it here, and then say display array numbers size. So we should see 1, 2, 3. Let me put a comment there. This is the only function that will execute. Run. One, 2, 3. So if a pointer can hold an address, we can send the array name, which is an address, the size to know how many times to iterate, and then we can loop through an array, right? So this is the relationship between pointers and arrays. The name of an array returns an address, pointers point to an address, so you can assign the name of the array to a pointer and thus do stuff like this or like this, okay? Okay, I won't take questions right now so that I can get through this, okay? So let me see here. Let's create another function, void, populate times table. We will use times table. This is a 2-dimensional array. So then we say, okay, we haven't defined that variable. We will. We haven't defined this one. We will eventually. Okay, and we can define them here. So we can say const int calls equal 10, const int rows equal 10. So we define them. Let's write some code for the populate times table. This is an example to show you how to work with a 2-dimensional array. Very simple example. I do not focus a lot on that, but at least you more or less know how they work, okay? So we have, what time is it? 6:53. Okay, no cheat, so that I don't have to keep you all too long, okay? This is from yesterday's class, so we write that code. This is rows, not rows, so rows. We need an include here, so we need to include IO manip or input output manipulation for that to work. What does that do? And why don't I focus on output? Because those are bells and whistles stuff. You can learn that on the internet. Set W means set width. So for each column, set a width of 5 spaces, okay? And then it'll right align it for you nice and neat. So that's the code. We come here and now let's display times table. It'll have the same signature. So notice what we're doing here. For integer I equals row, for I equals 0, I less than rows, then start, and then it'll loop inside for however many columns we are, right? And I'll go through that in the diagram a little bit. And then for the times table, do I times j. Is that correct? No, that's not correct. This is correct. I'm glad I looked at that, right? Because that's what we're trying to display, and this is the right code, right? So this is correct. So rows. So we loop through rows, we loop through columns, and then we say for ij of times table, do I plus 1 times j plus 1. Why? We start at 0, so we want to always start at 1 times 1, 1 times 2, 1 times 3, 1 times 4, and so forth, okay? So how is this working? Let's come over here, and let me jump to this one, and let me jump to the two-dimensional array. I'm not going to do the 10 by 10 table, okay? I just want to explain how the rows and columns are working. Okay, so if rows is 0, I is 0, rows start here. So for j equals 0, j less than columns, how many columns do we have? 2. So I 0, j 0 gets the first element. I have them backwards, right? So I 0, j 1 get the second element. I 0, j 2 get the third element, right? How does it look in memory? In memory, it's just a sequential block of memory. And notice we have 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. How does it find itself in memory? It uses this formula. Just like we did for the one-dimensional array, where I was like, well, how does it know where to find it in memory? Oops, that might be too big. Let me do like 14. I think that should be hopefully good enough. Control B. Row times number of columns plus column times data size. So let's start with an easy one, right? Row 0, 0 times number of columns 3, 3 plus column 0, 0 times 4, 0. So 100 minus 0 is the first element. But if we want this one right here, 2, 1, behind the scenes, the computer's like, okay, row 2, 0, 1, 2, row 2 times number of columns is still 3 plus the column is 0, 1, column 1. So 2 times 3 plus 1 is 7 times 4, 28. 100 minus 28, 72, right? So behind the scenes, that's how it calculates and knows how to find elements of the array, okay? And we go back. I'm sorry, but I'll have to keep on trucking to get this example out of the way and get you all out of here, okay? Luckily, it's been recorded, and you can go back and watch the video or stop by my office hour to ask questions, okay? Display times table. It has the same signature here. And I think I've already done that over here for the header. And then I can say, okay, let's do that. This is the output, so display, right? So we have the C out here. This is rows, not row. So again, for integer I equals 0, I less than rows, I plus plus, and then loop through all the columns across, right? So when you're in row 0, loop through all the columns. Here we only have 2, but it would be up to 10, and then go to the second row, right? So that's what's happening here. I equals 1, then it would be, okay, I equals 1 here, and then loop through all the columns, right? So that's what the inner loop is doing. The inner loop is visiting all the columns. And then after each column, we say display a new line so that we can have a nice, pretty table, okay? So we come back over here, and let's mute this piece. And then let's, we have to create some code in main, okay? So let me see here. We have to create the int times table of rows. So how many rows? 10. How many columns? 10. So we create a two-dimensional array like this one right here, but 10 by 10, okay? Not 3 by 3. Don't confuse this with C++, the tic-tac-toe program, okay? This is completely different. Don't get any ideas, so we're gonna have to do this for the tic-tac-toe. No. Like the tic-tac-toe program's already complicated enough, so we're not gonna do that. And then we can say, okay, populate, meaning add values to the table. And then we pass in rows. Oops, capital R, rows. And then display times table, pass in the times table rows. And that should create our two-dimensional array and output it hopefully nice and neat, right? So notice here, very simple, well, example, right? And that's how we can work with two-dimensional arrays, right? So the book has three-dimensional arrays. I will not have time to cover that, but you can always go into the book and see that example. If you really want to see it in action, I think if you go to my fall lectures, then you can see that, but we won't need it. You won't be quizzed on it or anything. Okay, so next time we will jump into arrays and dynamic memory and functions, and we'll be deep into memory management topics. Okay, so let me go ahead and stop this here.